Hi everyone, I'm Cheryl. In this example, we're going to describe and sketch the graph of the level surface described by my function f of x, y, and z equals x minus y plus z when c is 1. So let's begin by letting c equal 1. So I'm going to have the equation 1 equals x minus y plus z. Now, to see what that surface looks like, I'm going to look at some traces. So we're going to begin by looking at the trace in the xy plane. So this will be the xy plane. Okay. So I'm going to start out with z being equal to 0 for my trace. So if z equals 0, my equation turns into 1 equals x minus y. And if you want to, you can solve that for y and say that y equals x minus 1. So in the xy plane, which is this plane that comes out at me, I have the line y equals x minus 1, which means that the y-intercept is going to be at -1, which is going to be right here. And the x-intercept, if I set y equal to 0, will be equal to 1. So the x-intercept is right here. And I have a line that goes through those 2 points. Now I'm going to have a complete line, but I'm just going to draw this segment. But if you can imagine, that line's going to go forever in both directions. Okay, let's go ahead and look at the xz plane trace. Okay, so in the xz plane trace, let's go ahead and look at the trace where y equals 0. So if y equals 0, my equation turns into 1 equals x minus 0 plus z. Okay. So I can write that if I want to as z equals 1 minus x. Now, what I have again is a line, but this time my line is in the xz plane. All right, so let's see what happens here. If I write it like this, then if I want to find the z-intercept, the z-intercept is going to be 1, which is right here. If I want to find the x-intercept, I'm going to set z equal to 0 and solve for x. So x is 1, which is going to be right here. And again, I know that I have a line, and so I'll draw a line that connects those 2 points. And again, remember that line goes in both directions. I'm just going to look at that particular segment for right now, though. All right, last one. I've got the xy plane, the xz plane, and now I need the yz plane. And I'm going to look at the case where x is equal to 0. That's my trace that I'll use. So what does my equation look like then? It's going to be 1 equals 0 minus y plus z. And again, I'm going to go ahead and solve that for z. So z is going to equal 1 plus y. So again, I'm taking a slice that's parallel to the yz plane, which is the one that's straight against my board. So if I look at this, the z-intercept is going to be at 1, which is right here. And if I want to find the y-intercept, I set z equal to 0 and solve for y. That's going to be at -1 on my y-axis, and so that belongs right here. And again, I have a line that will connect those 2 dots. And remember, that line goes forever in both directions. Now, what have I created? Well, this little triangle, if you can envision it, is going to be a plane. And because these lines actually continued forever in both directions, it's a plane that this triangle lays right on top of. And that's my surface for my function. I hope that was helpful. Thanks.